Good morning, Math 30s. This video is going to be the last lesson in our unit on polynomial functions and equations. And the lesson is going to be on modeling and solving problems with polynomial functions. So we're going to apply it, the concepts that we learned to solve problems. So what this first question says is, Bill is preparing to make an ice sculpture. He has a block of ice that is 3 feet wide. So draw yourself a little rectangular prism, and we'll say that this block of ice is 3 feet wide, 4 feet high, and 5 feet long. Okay. Bill wants to reduce the size of the block of ice by removing the same amount from each of the 3 dimensions. He wants to reduce the volume of ice to be 24 feet cubed. So a couple of things that we need to realize. When we're calculating the volume, we know that volume is length times width times height, right? So if I were to calculate the volume currently as it stands of this block of ice, it would be 5 times 3 times 4. And if we multiply 5 times 3 times 4, we would get the volume to be 60 cubic feet. Okay, so that's what the volume of the block of ice would be. But then what it says is that what he wants to do is he wants to reduce the size of the ice by removing the same amount from each of the 3 dimensions. So this dimension is 5 units, and he wants to remove a certain amount from that length. From the width, he wants to remove the same amount, and from the height, he wants to reduce it by the same amount. So if I said, okay, well, what's the new volume of our block of ice? We know that volume is equal to length times width times height. So now the volume would be 5 minus x, 3 minus x, and 4 minus x. And then what we do is we want to write this as a function. So we say the volume as a function of x is equal to 5 minus x, 3 minus x, so I'm just writing this in proper function notation, and 4 minus x. So A says write a polynomial function to model this situation. So this would be the answer for A after he's removed the certain amount from each side. After he's removed x from each side, this would be our polynomial function. Then B says, how much should he remove from each dimension? So now we have to actually calculate what they want x to be. And it says he wants to reduce the volume of ice to be 24 cubic feet. So we had it before he reduced it at 60 cubic feet. And now what he wants to do is reduce it to 24 cubic feet. So for B, we're going to put 24 where volume is, 5 minus x, 3 minus x, and 4 minus x. To figure out what x is, probably one of the most efficient ways would be to graph this on our calculators. And what we're going to do is we're going to graph this in y1, and we're going to graph this in y2. Now remember that this is going to be a straight line at 24, at y is equal to 24. So we're going to have to change the window settings. And then we're going to be calculating what x is. So go to your calculators. And I actually already have the second question typed in, so I'm just going to unselect that. And let's type in 24. And then let's type in our 5 minus x, 3 minus x, and 4 minus x. So open bracket, 5 minus x, close that bracket. The width was 3 minus x, and the height was 4 minus x. And then what I'm going to do is I'm going to go to my window settings, and I'm going to change my Y maximum to at least 30 because I know that there's going to be a line coming at 24. I changed my scale factor to be 3. So I just take that 30 and I take off a 0. Let's see what this graph currently looks like. So there's my volume at 24, and there is my polynomial. We are looking for the intercept. So second function, calculate, and we are looking for number 5, an intersect. So go close to your intersect and you hit enter 3 times. Enter, enter, enter. And what we get is when x is 1, y is 24. So the intersect that we get is when the x value is 1, the y value is 24. So what you have to realize is the x value is the amount that we're reducing. So the x value, we're reducing 1 foot from each side. So let's write x is equal to 1 foot. And it's saying if you reduce each side by 1 foot, you will have your max volume at 24 feet cubed. So let's actually check to see if that's correct. So the B was how much should he remove from each dimension? So we want to say the answer for B would technically be he would remove 1 foot from each dimension, and then we will check. Okay, so that's how much he's going to remove. If I go back up to my little ice cube, and if I subtract 1 from each dimension, what I'm going to have is I'm going to have a length of 4, a width of 2, and a height of 3. And if you type in your calculators, 4 times 2 times 3, so 4 times 2 is 8, and 8 times 3 is 24. Then he would have reduced his volume of ice to 24 cubic feet. Okay, so that's how we do this first question. Let's look at the second question, which is going to be a similar type of question. We're just going to be thinking a little bit more about this. So what this question says is we have a piece of cardboard, okay? And the cardboard is 30 centimeters long and 25 centimeters wide. So let's label our cardboard 30 centimeters long and it's 25 centimeters wide. And then what they're going to do is they want to cut out these little squares from this cardboard. So they want to cut out these little squares. And if you cut out these 4 little corners, they're going to fold these sides up and it's going to make a lid. Okay, so it says each square of side length X are cut from the corners, and then these lengths are going to be folded up and you're going to have a lid. So what they're telling you is that this piece of cardboard is 30, but what we're going to cut out is this piece here, which is X, and this piece here, which is X, right? So we're going to cut the new length is going to be 30, but what do I have to subtract if I cut out an X and an X? The new length would be 30 minus 2X. Okay, this guy here, it's 25, right? So the entire distance is 25. And then we're going to do the same thing. We're going to cut out a side length X and X is what we're going to be cutting out from this. So that new distance is going to be 25 minus 2X. So this is going to be our new lid. So 30 minus 2X and 25 minus 2X. So A says, write a polynomial function to represent the volume of the box in terms of X. So let's do that. We know that the volume is length times width times height. So the volume according to X is going to be the length of the box, 30 minus 2X, times the width of the box, 25 minus 2X. Now the height of the box, when I fold up these sides, the height of the box is going to be X, right? So the height of this box is going to be X. So length times width times height, that would be your equation to model the polynomial function. So let's box that in for A. Okay, let's do B. Graph the function and what is the domain. So a few things. You're going to take out your calculators and we're going to type this into our calculators. Now, we're going to have to change the window. Okay, so remember that the y-axis is volume. So without subtracting anything, if I was to calculate like the volume without subtracting, it would be 30 times 25 times whatever this height is. So let's say like the height was 2. So volume is equal to 30 times 25 times 2. I'm just doing this because I want to see what like my window setting should be for my y values. So if you type in 30 times 25 times 2, we get 1500. Okay, so that will help us determine like what I'm going to change my window settings to. So go to your calculator and go to y is equal to. I'll clear this question. Type in your first equation here. So type in the equation, the 25 minus 2x, 30 minus 2x, and x. And I want to show you what it looks like if you graph it on just a Zoom 6 standard. So if I graph this on a Zoom 6 standard, it looks like nothing, right? We have to change our window. So our x values are our lengths, right? So it's like, what are the possible x values? So I'm going to change this to maybe 20. I'm going to change my x values to 20. So go to window and let's change our x max to 20. We might have to switch that. I'm going to change my scale factor to 2. When I go to y max, I'm going to pick a number bigger than 1500. So let's maybe go to 1700 for y max. So if I go to 1700, I'm going to change my scale to 170. Let's see if we get a better looking graph. There we go. So we have a better looking graph for this. Okay, so this is sort of what our polynomial function looks like graphed. Let's talk about how we would get the domain of this graph. So what we want to do to get the domain of this graph for B is we're going to take each of our lengths and we're going to say, so 25 minus 2x, oops, actually I'll take the 30 first. So 30 minus 2x. And the domain restriction is that our x has to be bigger than 0, right? That's going to be like what our restriction is, because if we're taking out a side length, we can't take out a negative side length. I'm not going to take out 0. So my restriction is this value must be greater than 0. So if I solve for this inequality, subtract 30 from both sides, and you get 2x is greater, sorry, negative 2x is greater than negative 30. Then when you divide both sides by negative 2, remember what happens for Math 20-1 when you divide both sides of an inequality by a negative? Your inequality sign switches. So I have x is less than 15. That's going to be one piece of my domain. I'm going to use this for my domain. Then I'm going to take, let's take this guy, 25 minus 2x. So 25 minus 2x, I'm going to do the same thing. I'm going to say that that has to be greater than 0. So I'm going to isolate for x, and I always, when you're doing an inequality, you want x on your left-hand side. So subtract 25 from both sides, and you get negative negative 2x is greater than negative 25. And here, divide both sides by negative 2. We got to flip our inequality again, and we get x is now less than 25 divided by 2 is 12.5. Okay, my last piece of my domain, it's going to be this. And the height, the restriction, is x is greater than 0. Okay, so if I was to put all three of these on a number line and to figure out what my domain is, all three of these on a number line, I have 0 here. And I say that x has to be greater than 0. So I'm going to shade this piece, right? And that's going to represent this. Then I'm going to put 15 in. So 15 here. And x has to be less than 15. So that's like all of this. Then I'm going to put that 12.5 in. And x is less than 12.5. That would be this piece. Maybe I'll put it down here. That would be this. So what you have to do, your domain is what was common to all three of these. And what's common, where they overlap, is from 0 to 12.5. So the domain of this graph, where all three of these overlap, the domain is going to be x is such that x is less than 12.5, greater than 0, comma, x belongs to the set of real numbers. So that would be my domain. You have to figure out the inequality for each x. You put it on a number line and you say to yourself, where do these three overlap? And it will be between 0 and 12.5. To get C now, it says to the nearest cubic centimeter, what is the maximum volume of your box? Okay, so what we have to do, they want the maximum volume. You need to go to your graph for that. From 20-1, this is a maximum. So we need to calculate this on our calculators. Second function, calculate. We're looking for number 4, which is a maximum. And you're going to go to close to where your maximum is, and then you're going to go left of your maximum and hit enter. Go right of your maximum and hit enter. And then when it says yes, you hit enter again. So we are getting, when x is 4.5, the max volume is 1512. So we'll write this down. When x is 4.5, the max volume is 1512. So I'm just going to erase this. Okay, so let's write that down and let's see if we could figure out what that means. So it says when x is 4.5, y is 1512. To the nearest tenth of a centimeter, so I'll put a 0 in there. Okay, so we know that this is our x value, and I'm going to write 4.5. If I go up to my units, the units are centimeters. So this height, I hope you could see, is going to be 4.5 centimeters. And if x is 4.5 centimeters, what they are saying is that the volume of the box, when x is 4.5, the max volume is going to be 1512.0 centimeters cubed. So let's see if these numbers work. So we're going to take 4.5 and we're going to calculate the length, the width, and the height, right? So this is our length, this is our width, this is our height. So the length is equal to 30 minus 2x. Length is equal to 30 minus 2 times 4.5 because they're taking out 4.5 from each x value is 4.5. And if you type that in your calculator, 30 minus 2 times 4.5, you are going to get a length of 16 centimeters. Okay, let's do the width. The width of this is going to be 25 minus 2x. So the width is going to be 25 minus 2x. So again, when I see x, I need to substitute in 4.5. So width is going to be 25 minus 2 times 4.5. And if you calculate that on your calculator, 25 minus 9, 25 minus 2 times 4.5, let's double check that. So 25 minus 2 times 4.5, we are going to get 16. So the width of this is going to be 16 centimeters. And the height of the box, if I go back up here, the height of the box is just x, right? So x is 4.5. Okay, let's check. So if I cut out that side length of 4.5, let's type in length times width times height, and let's see if we get 1512. So just let me erase this. So going back to our calculators, we're going to type in the volume of our box as length times width. I feel like I did the length wrong. I've got to check this guy. I'm going to double check this guy. 30 minus 2 times 4.5. Let's check that one. 30 minus 2, 21. This should be 21. Okay, so we have length times width times height. So I've got 21 centimeters times 16 centimeters times 4.5 centimeters. So let's check if we're right. 21 times 16 times 4.5, and then there's my max volume of 1512. Okay, so that's how we would do C. And when it says what are the dimensions of the box, we have that labeled here. It says to the nearest tenth, so I guess I should say zero point 0.0 centimeters. This one should be 0.0 centimeters and 4.5 centimeters. Those are the dimensions of the box. The volume of the box would be 1512. Last question. Okay, it says 3 consecutive integers have a product of 210. So first you need to know what a consecutive integer is. And what a consecutive integer, so integers are, remember, the positive and negative numbers. And if I said like, okay, what are 3 consecutive integers? 4, 5, and 6. Those are consecutive integers. Consecutive means it comes one right after the other. And then if you said, okay, well, what's the product of 4 times 5 times 6? We get 120, right? So 4 times 5 times 6 would give me 120. So what they're saying is, how could we figure out what 3 consecutive integers are that when I multiply them together, I get negative 210? So how we would do this is we would do the following. I'm going to say that this first integer, I'm going to call it n. Okay, so that first integer is, I'm going to say that's n. Then if I had to come up for a formula for 5, that would be 4 plus 1, right? So if I had to say, well, what would 5 be? It's 4 plus 1 or n plus 1. That's how I would get 5. And then how do you get 6 starting with 4? It would be 4 plus 2. So my third one would be n plus 2. So this is how you write 3 consecutive integers. Your first integer is n, your second consecutive integer is whatever that first number was plus 1, and your third consecutive integer is whatever that first number was plus 2. Okay? And then they want these 3 consecutive integers to be multiplied to negative 210. So 3 consecutive integers multiplied to negative 210. And then what we're going to do is we're going to graph this because that's the most efficient way. Let's punch this in y1 and let's punch this in y2. Please realize, so you just have to sort of start realizing things, that this is going to be a straight line at negative 210. So I'm going to bring my y minimum down to at least maybe 250. And then for my numbers, for my x values, I'm going to go from maybe negative 10 to positive 10. So let's punch this in y1, this in y2, see what we get. Okay, so go to y1 is equal to, and let's put in our x is our first integer, x plus 1 is our second integer, and x plus 2 is our third integer. So let's do that. And then they want the product to be negative 210. So let's get that product in there. Let's change our window setting. So let's put that, maybe let's go to minus 300, right? We know there's going to be a line at negative 210. So let's go to, actually I'm going to do just going to quickly do a Zoom 6 standard. I want to reset my window. Okay, so let's go back to window. So let's go from negative 10 to 10, and let's set our Y minimum at negative 300, and my scale factor I'll do 30. When I graph this, why am I getting a syntax error? Okay, the reason why I was getting that syntax error, I had a minus in here, like minus 210, and I had to change that to a negative. So let's see if this works now. Whew, it works. Okay, let's figure out what this is. So I've got to go second function calculate, number 5 intersect, and we're going to get the intersect. So bring your cursor close and hit enter 3 times, enter, enter, enter. And I'm getting my x value or my n value of negative 7. So let's write that down. N is equal to negative 7. I'm just going to pause for 1 second. Okay, let's finish this off. So what I got is that my first integer is negative 7. So n is equal to negative 7. My second integer, if it's consecutive, is negative 7 plus 1. So negative 7 plus 1 would be negative 6. That's my second integer. And my third integer, if I add 2, it would be negative 7 plus 2, which is negative 5. So my three integers that are consecutive are negative 7, negative 6, and negative 5. Those are my three numbers. Let's check on our calculator if they multiply to give me negative 210. So on my calculator, I'm going to type in negative 7 times negative 6 is the next consecutive times negative 5, and it works.